But I think just good management, good husbandry, um, good biosecurity, keeping the pathogens out. Um, I think all of that is actually probably the most fundamental thing for reducing antimicrobial resistance.
Hello, everyone. I'm Laura Greiner, your host for today's Swine podcast. And with me today, I have Dr. Noelle Noyes, who is an assistant professor at the University of Minnesota in the College of Veterinary Medicine. Noelle, how are you today?
Good, thanks. How are you?
I'm doing well. It's good to have you on today.
Good to be here.
Good. Before we get started, I don't think many of our audience may know who you are, as I know you're relatively new to the university. And so maybe I'll have you do a quick introduction about yourself and kind of your background, if you don't mind.
Yeah, sure. I'm originally from upstate New York, in a little town called Vernon or Oneida. Maybe people might know. If not, it's sort of between Utica and Syracuse. And before I got onto the veterinary track and the science track, I had a couple of different careers. But most relevant to this discussion, I got my dual degree, a DVM PhD at Colorado State University. And that program is such that you sort of get the PhD in the middle of the program. So that was in about 2015. And then I went back and finished up vet school and graduated in 2018. And then I took my current position at University of Minnesota in the Department of Veterinary Population Medicine in 2018 as well. So, and that's where I've been since then. So
Very good. Yeah, you've had quite a journey around the U.S. to get to Minnesota for sure. Well, as we were talking a little bit beforehand, Noelle, your background is in microbial populations or microbiomes, and a little bit in antibiotic resistance as well, or antimicrobial resistance. And it's not just swine focused, so it's kind of diversified along a couple of different species, cattle included. And so what I think I'd like to kind of start with is maybe let's have some discussion around antimicrobial resistance. It's something that I would have said 5 to 10 years ago, we heard a lot of discussion in the swine industry. It's still there. We certainly are monitoring antibiotic usage and so forth, but I maybe don't hear it as high on the list. And so where are we currently in terms of monitoring antimicrobial resistance and understanding what's happening within our barns?
yeah, it's interesting that you say that. I think I agree with you that I guess sort of some of the fervor around antimicrobial resistance has somewhat subsided in the past few years. Potentially some of that is because there were some big changes made to antimicrobial use guidelines for veterinarians a few years ago, and potentially we're waiting to see like what the impact of that will be. I also, from my perspective, I think that within the past few years, we've generated a lot of new knowledge about antimicrobial resistance and just how complex it is. And in my opinion, a lot of that research is telling us that it's not going to be as simple as just reducing use in order to control resistance. And so because that complexity is getting like a more robust evidence base behind it, I guess, I think we're in a bit of a period of time right now where we're waiting to see how we can use this new information to actually generate like evidence-based guidelines, and not just about antimicrobial use, but other things that we are starting to understand will impact resistance. So potentially that's one reason why too, is that the science is sort of at this stage where we're trying to make sense of it before we make the next step or, do the next applied thing.
Mm-hmm. That's interesting. So if we don't think it's coming from antibiotics, if the antibiotic resistance isn't necessarily highly correlated with antibiotics, where is it coming from?
Well, I think that antimicrobial use and the pressures that can apply on a microbial population is really important, but it's not the full story by any means. And when we talk about trying to reduce resistance that already exists, simply removing that pressure in some cases probably won't reduce the resistance necessarily linearly or even in the shorter medium term. And so we need additional tools and approaches for thinking about controlling resistance. And in my mind, that comes down to basically trying to manipulate microbial populations, and like nudge their evolutionary trajectories so that resistance that's there can diminish or new resistance doesn't emerge as readily. And so, yeah, that's sort of where our research focus is right now.
Hmm. So that's kind of an interesting take. So we're talking about the microbiome at this point, and we're talking about basically population shifting. So finding a negative population and pushing out the positive is what I'm hearing you say.
Yeah, I mean
Um,
that could be one approach. I mean that's almost like the refugia, idea with parasites, right, and resistant parasite populations. Yeah, but I think that there's some really new work that's come out recently where, if these resistance genes are within certain genomic contexts within the microbial population, there's just no cost to the bacteria to be carrying that resistance gene. So removing the antibiotic pressure is probably not going to like meaningfully change the prevalence of that resistance gene in the population because again, there's no selective pressure on it in that way. So yeah, so in those scenarios, and of course it's going to differ by resistance gene and it's going to differ by bacteria that's carrying it and the host population and all sorts environment, all sorts of things, right? But we have the tools now scientifically to start being a bit more predictive and evidence based about what will work and what won't work for given resistance patterns, I think. So
mhm, mhm. Can you give us some clues as to what might work to help push those populations in the direction we want?
well, I think when we manage animals generally, we're managing their microbes, and so I'm interested to know, as animals are moving through these very dynamic phases of life, which that's early life, and in humans we spend the majority of our life in this adult stable period. But if you think about commercial pigs or beef cattle or dairy cattle, like they are constantly in this, exponential growth phase or like under high burden of lactation, things like that. And that's a very dynamic period for the microbiome. So the theory or the hypothesis, I guess, is that we could potentially like nudge or manage the host microbiomes using just management techniques. That's my hope. Is that it's not necessarily adding something to the system or taking something away. It's just managing the system with keeping in mind that we're managing the microbes in that system and in the host as well. So
Hmm. Do you see that antimicrobial resistance theory also applying to maybe some of the enteric pathogens that we also talk about and microbiome shifting, or is that completely different?
no, I think it's a very common theme between the two, right? So it's both the evolution, so like what genes are bacteria acquiring and getting rid of and what mutations are they having, but it's also ecological, right? It's what bacteria are out competing each other within the gut of the host and how are our management practices, either promoting that competition or hindering it. And so it's one and the same. It's really understanding like this invisible world of microbes that's like all in our barns and in our animals, and understanding how we can sort of safely manipulate it for improved outcomes. That's the goal, at least.
Hmm. Yeah.
Scientific applied science goal.
Yes,
Yep.
exactly. And I think for some of our listeners, right, that's some of them might be getting a little bit weary of hearing about microbiomes, but I think that that's the piece that they have to understand is that we're still learning about it. And right, just today I had something pop across my email about microbiomes and weight loss in humans. Right?
The microbiome has like been promised for a long time as sort of, this we're going to have so many new pharmaceuticals and like so many new things coming from the microbiome science. And I still believe that that's true, but I think that it was always a bit naive to think that we would be able to like really quickly identify like specific, metabolites or specific probiotic type bacteria that would across all populations and age groups and across all physiologies and all farms would have the same effect. The microbiome we know now is it's just too complex and it's too dynamic to probably find something that is universally effective in that way. So yeah, it's just more nuanced. So I think that the discoveries are coming, but they're just going to be a little more hard fought than potentially we realized when we first started doing microbiome research. Yeah.
Well, and I think that's what's really interesting too. But yet at the same time, I think that can frustrate people. So, how do you start the process of assessing when we know, oh, we changed the antibiotic, microbiome changed, we added something to the water, microbiome changed? So, how do you look at a population and really start to assess what's real in the microbiome and what organisms really have the greatest impact? How are you stepping into those questions?
So, first of all, it starts with very high quality science. So, lots and lots of like positive and negative controls, lots and lots of controls on potential confounders. We measure a lot of things. And study design is also very critical. So I'm actually an epidemiologist by training, and understanding like how we can what types of study designs are most appropriate or are most likely to give us meaningful information, meaningful results is key. That's been a real weakness in the microbiome literature, in my opinion, for a long time. And then understanding the analytics, like, so once you have a well-designed study, you've meticulously collected samples and accounted for potential contamination all along the workflow. I mean, we probably throw 8 or 9 different controls into our work throughout a workflow. And you've got sufficient sample size, which is another study design issue. Once you've got that, then you really have to know how to perform the most rigorous bioinformatic and statistical analysis that's going to give you the most robust results that you can generate from that type of data.
Hmm. Yeah, so I think that's something we hear a lot in research these days is we'll just take a microbiome sample here and with maybe no exact set on it, right? It's kind of secondary thought, but we're going to capture it anyway because who knows, maybe somewhere down the road we might need it or want to look at something. And that is, from what I'm hearing you say, is not the way to approach this at all. Um, so maybe for some of those, when you talk about a positive and negative control, what does that look like when you're doing microbiome work?
Yeah, so on the negative control side, one of the things that has been very well documented now in human microbiome research is the issue of contamination within the microbiome data. And contamination can come from a lot of places. So what we typically do is we'll take multiple quote unquote negative controls while we're sampling on a farm. That includes sampling like the air as we're collecting the actual samples that we care about. So if it's a skin sample or nasal sample, fecal sample, we'll take a sample of like the environment basically that we're sampling within. We'll take negative sampling blanks that just stay in their package when we're on the farm and we take them back. We take negative samples while we're in the lab. We do everything in the hood. Um, we do negative extraction blanks. So when we extract DNA, we do extraction blanks, we do library prep blanks, we do all these negative blanks. And then when we sequence all of those, we are able to determine with some level of confidence like what are the bacteria that are actually like not in the original sample, they just the sample got contaminated somewhere along the workflow, versus what are true microbes in that sample. And that's important to know, because otherwise you might be finding something that's quote unquote significant that actually wasn't in your sample to begin with. So yeah, so that's been a big thing. And then on the positive control side, it's really tricky to come up with positive controls for microbiome. Like, you think of a positive control as if you're working with a single pathogen, that's pretty easy to understand a positive control, right? You would maybe run a sample with a known pathogen in it. But for microbiome, we're looking at like thousands of species of things. So what's the positive control for that? So there are several different ways to to actually use positive controls, like mock communities in different ways. And so we use several different methods to do that for positive controls. Yep.
That's very interesting. So I think that's some food for thought for some of our listeners that maybe are doing that out in the field, to maybe think about some places, at least from a negative control standpoint, that they could easily be checking to help remove some of that variation that we're finding in our sampling.
Yep, for sure. Yeah. And of course, storage, we store everything in -80, and it's there's definitely logistics to be figured out ahead of time, usually when we're thinking about microbiome. Yep.
Mhm. Absolutely. How about from an analytic standpoint? We see a lot of microbiome data that talks about 16S typing. And, I've heard recently that's really not the way to go if we're going to be serious about microbiome testing. So, what do you recommend, or what are your thoughts around how we should be analyzing our samples?
Yeah, it's interesting because I because I came at microbiome from the antimicrobial resistance work, I actually had never done 16S. I started out with shotgun metagenomics, which I can explain. So shotgun metagenomics is where you take all of the DNA from a sample and you sequence all of it. So that's going to include, sus scrofa DNA for a lot of the samples, like host DNA. It's going to include like parasites that might be in there. It's going to include all the viruses, all the bacteria, fungi, like everything that's in there. And we analyze all of that. 16S, which is much more common. I've done a lot of 16S now, but it was actually the second thing that I did. Usually it's flipped for people. They'll start with 16S. So 16S is where 16S is a gene that is ubiquitous across bacteria and archaea, but not other microorganisms. So pretty much just bacteria. And it's a very nice gene because parts of it are super conserved and parts of it are very mutable. So they mutate like a lot over evolution. They've mutated a lot. And so you can design primers to bind to the conserved parts, but then you sequence the hyper variable parts. And so that allows you to sort of assign a hypervariable fingerprint like to different taxa of bacteria, but you're only sequencing that portion of the 16S gene, and all the other DNA is not sequenced. So it's a very different workflow. Your question about is one better than the other? It really depends on your question. And so I'm always going to say that as a researcher. Yeah, but it really is true. I mean, I think it depends on your question. And there's other things like metatranscriptomics, metabolomics, and these other assays that are not at the DNA level, but at like the RNA or the like metabolite level, that are really informative, on top of shotgun metagenomics and 16S. So again, it sometimes it takes all of these methods combined, including like we still do a lot of culture work, a lot of traditional microbiology to supplement all of this omics work that we're doing. And that gives us additional information that's usually really useful, actually. So it's a combined effort.
Yeah, it's very complex, right? I heard you rattle off a couple different omics in there, and for people who aren't as familiar with it are probably already like, oh my gosh, I can't even begin to know where to go. But I'm going to kind of go back. I'm going to circle back to antibiotic resistance and our antimicrobial resistance. So we've talked a little bit about identifying organisms within the gut. We've talked about antimicrobial resistance. So when you're measuring if a population is shifting away from an antimicrobial resistant gene, how do you do that?
Well, that could be done a couple different ways. So a good example is a project we just recently published, actually two different publications. This was done in collaboration with Dr. Carissa Odland, who's now at Holstone and was at Pipestone and got her master's degree recently at Minnesota, and other collaborators at Pipestone. So in this project, we did both a culture-based approach. So we looked at E. coli and Enterococcus, and we looked at their resistance profiles. We also looked at metagenomic resistance genes, and yeah, in both cases, we got different information from those workflows about how antibiotic exposures in pigs in the nursery phase, actually all grow finish. We went all the way through marketing. How antibiotic exposures in the context of a PRRS challenge impacted the resistance profile in the feces of those pigs. And we did that again with the culture workflow, which is one paper, and then the metagenomic workflow, another paper. And our ultimate goal is to try to combine those together and understand how maybe they give us the same information or different information. Yeah.
Mm-hmm. Mm-hmm.
Yep. In terms of measuring the resistance genes, again, we take all of the DNA from each sample and we do shotgun metagenomics, which generates like these short pieces of DNA sequence, like the AGCTs in all of that DNA. And bioinformatically, we're able to pull out the sequences that come from resistance genes. And so we identify those sequences and we count them. And that is sort of the starting point for understanding like shifts in the resistance profile in those pigs.
Mm-hmm. So you are actually doing quantification work, essentially.
Yeah, again, that's an area of debate within the metagenomic community. Like, at what level are we getting quantification? Is it relative sort of quantity or is it absolute? And there's sort of a lot of new ways to try to do like absolute quantification, which I think are really interesting that we're trying out in our lab. But it's sort of a cutting edge right now, I guess, some of that work.
Mm-hmm. That's very good. So I think you've given a lot of our listeners some really good things to think about, particularly those that are interested in microbiomes and antimicrobial resistance and the process and how to fully research it. If you're a veterinarian in the field and you're working on it or working within a company. But as we kind of wrap up, if I'm a producer listening to this, what can I do to counteract antimicrobial resistance based on some of the information you're learning today?
It's probably gonna sound like, oh, I know you're gonna say this, but I think just good management, good husbandry, um, good biosecurity, keeping the pathogens out. I think all of that is actually probably the most fundamental thing for reducing antimicrobial resistance. And very interestingly, in one of the papers that I referenced, um, we took samples from these pigs like after they were challenged with PRRS, but before they received any antibiotics. And then we took samples after they got antibiotics. And one of the really interesting findings to me was that the resistance profile shifted significantly after the virus challenge before any antibiotics were even given. And actually, that shift was a bit more pronounced than any shifts that occurred after the antibiotic administration. So I do think that just disease itself shifts the microbiome and therefore the resistance profile. And, so that's just even more reason to, do all of those fundamental like basics, right? They're basics, but they're fundamental to pig health and production and also to reducing antimicrobial resistance. So basically minimizing the need to use antibiotics, minimizing disease, I think are all probably going to help with the resistance issue.
Mm-hmm. Very good. So basically, after the pig developed a fever, was exposed to PRRS, you saw more antimicrobial resistance or less when you said there was a shift?
Well, it was a shift, and we sort of saw sort of like a reappearance of very rare resistance genes within the microbiome. So when pigs are born, they have a very diverse resistance profile. We've seen this across many animals. It's not easy to explain because at that point in their life they haven't been exposed to antibiotics usually. And we see that even when the mother hasn't been exposed to antibiotics. They just have a diverse resistance profile, maybe because of the microbiome at that point. We don't know for sure. So those then the resistome, the resistance profile sort of stabilizes. as they get older. And we saw this in the research population we were working with in this study. But then when we gave the purge challenge, all of a sudden, like some of those resistance genes that had made the profile very diverse early in life, they sort of reappeared within the data. And so we don't know like if that's again because of like shifts in the microbiome, or there is some evidence that host inflammation can basically like induce bacteria to transfer resistance genes back and forth by horizontal gene transfer. So host inflammation of happens during disease like viral or bacterial challenge. And so is that actually in and of itself a risk factor for an increased antimicrobial resistance, especially for these like rare genes that we see? We don't know. The study wasn't designed to answer that, but it was a very interesting observation.
Mm-hmm. Yeah, certainly something to think about, for sure. And that's really actually quite fascinating and a little bit unnerving, really, at the end of the day, to think about what happens when you have a fever and inflammation. But that's
Yeah,
okay.
yeah, and that's why I say it's like we manage animals, we manage their microbiomes, and that includes health status, right? And so that's why I say just like those basic things to support, pig health and productivity are probably helping with resistance in that sort of indirect or even direct way, I guess. Yeah.
Mhm. Yeah, that's very good. And it's great advice. I mean, it's still the same thing that we would tell producers anyway, but it provides a new sense of meaning as to why. And I
Hmm.
think that's right. That just kind of reiterates and brings home exactly what we want our producers to be thinking about. So
Hmm.
very good.
It is time to our famous three.
Well, we kind of are at about our time limit. So before we leave today, there's a few questions we like to ask our guest speakers. The first one would be is do you have a book or a reference that you would recommend for our audience, kind of based on the topics we talked about today or related to swine?
Yeah. So if you're new to sort of the microbiome concept and how important it is and what's the state of the science, there's actually like a really nice book. It's about the human microbiome more, but it's a good read. It's called "I Contain Multitudes" by Ed Yong, Yong. And I think it's just like an easy read. It's not. He's a scientific writer, and so it's like written to be accessible and like fun to read, I guess, about the microbiome. Yep. So that's one I would recommend.
Very good. How about something that's not related to pigs or the microbiome? Is there anything that you're currently reading or have recently read that you would recommend to the group?
Yes. I recently read the book American Dirt, which I just like couldn't really put down. It was just a really good read and it was really a beautifully written book. And yeah, I recommend that as a piece of fiction. It's a fiction book.
Very good. The last question we like to ask our guest speakers is really kind of a personal question, but if you can think of someone in your life that you viewed as successful and you define success however you want, what's a key characteristic that they have possessed that you think has allowed them to be successful?
Yeah, so I would say the person I'm thinking of has always been like very responsive and flexible to the situation and able to sort of evolve um, over their entire life to different challenges and situations. And at the same time, though, like maintain, like staying true to their core values, I guess I would call them. And so that sort of balance of flexibility and also steadfastness in certain areas, I think, uh, yeah, has made that person very successful, and I think it's a good combination that I strive to attain. Yep.
That's a good one. I haven't heard that one in a long time. So I think I've heard flexibility before, but the other portion I haven't. So I think that's actually really an interesting trait. And I think it would be one that's very valuable for success. It's very good. Yeah. Noelle, our time is about up. So I do want to thank you again for our conversation today. For our audience, this is Dr. Noelle Noyes, who is at the University of Minnesota. Noelle, thank you so much for your time.
Thank you.
Imagine if, with a few key concepts, you could have the potential to create a massive positive impact by bringing from hundreds of thousands to millions of dollars for swine producers. Join us on this small group and go to the next level of swine nutrition on this 7-week-long elite online training in applied swine nutrition and feeding by myself and my world-class invited speakers. Additionally, you enjoy an exclusive community to exchange ideas. Go now to www.eliteswinenutritionist.com.